Welcome to Multivariable Calculus. So today I'm going to start off with the very first chapter and section 11.1. So this section and chapter aren't going to give you too much trouble, but I'll still skim through the textbook fairly quickly and do some example problems. Due to the fact that this section is so simple, there's not much I can do to help other than do example problems, so your best bet is to just read the textbook. Alright, so I'm going to go straight to example 2, finding the component form and length of a vector. So, in this problem, we're going to find the component form and length of the vector v that has initial point 3, -7, and terminal point -2, 5. So essentially when you're finding the component form of a vector, v in this case, you're going to subtract the first x value from the second x value. So in this case, the terminal point minus the initial point. So you're going to have -2 minus 3 for the x value of v, and for v2 you're going to have 5 minus -7. So with that you're going to get the vector v equals -5, 12. And then to find the length or magnitude of v, all you're going to do is put the x and y values underneath the square root and square both, and in this case you would get -5 squared plus 12 squared, square root of that, so square root of 169, and that will give you a length of 13. Alright, so generally speaking, in all of these videos we'll be going over the theorems. So we're starting off with theorem 11.1, properties of vector operations. However, this theorem you should already know, as you've learned the commutative property, associative property, distributive property, all those properties in elementary school most likely, so there's really no need to go over it in this case. You're basically applying the same principle, but this time with vectors. Alright, so I'm going to jump ahead to example 4, finding a unit vector. So if you looked at theorem 11.3, then you should already have a good understanding of this. So essentially all you're doing is you're finding a unit vector in the direction of a specified vector and verifying its length. So essentially all you do is take that vector and then put it over the magnitude. So in this case you have -2, 5, and you're just going to put that over the magnitude or length of that, which in this case is root 29. And then when you have each of those components, you find the magnitude of that again, and then you'll get length 1. Alright, so at this point you should be ready to begin the exercises for section 11.1.